Welcome to our webinar series for professionals.
So welcome everyone. It's 4 o'clock Copenhagen, where we now have a king and a queen. I'm Anne-Catherine, co-founder of Nordic Laboratories and DNA Life, where we are dedicated to support and change healthcare and health optimization through functional medicine and personalized medicine. And today we are going to talk about organic acids as a follow-up from the presentation that we had last year. Today we're going to have focus on methylation, toxic exposure, mitochondrial dysfunction. So right down my alley. And we have Dr. Lena Powell with us, naturopathic doctor with us again today. We had such great feedback on your presentation last time. You're a great presenter. So all of you who missed the last one, you're in for, not to make you too nervous, of course, but no, you're in for a treat. Because today is all about optimal nutrition and biochemistry as we prefer it and as we love working with it when we're dealing with functional medicine. So Dr. Powell is the medical educator specialist at Genova Diagnostics. So that's why she's been chosen to help us here and entertain us a little bit for the next hour or so. Remember everyone that we will be recording and sharing the recording, and also put questions in the chat. Then I will take note of them, and then at the end I will do a Q&A and try and pull as many of the questions into the Q&A if possible. So use the chat box or chat with each other and say hello and all that. So nice to see you all from different countries as always. And I just realized I came into the office today in Copenhagen, in the head office where I am, and I had to have a glass of smoothie. We did the Nordic smoothie that we do for lunch, and I found this glass in the cupboard. And I realized this is a glass that I bought when I was 20 years old in Venezuela, so only 5 years ago. No, so actually 30 years ago, I bought this glass in Venezuela, and because I traveled across the Atlantic Ocean in a yacht, and that was, for some reason, this glass I chose to bring back with me. And I was in the lunch room with the people working here at the head office, and they're all from all different. There's one from Ukraine, there's one from Pakistan, there's one from Egypt, there's lots of nationalities here as well. And so somehow this glass has just followed me today. And it's a little bit where it has taken Nordic and DNA Life to be global. So nice to see you everywhere in the world, and also you, Hannah, in Copenhagen. So anyway, I will pass on the stage to you, Dr. Powell, so that you can share your screen, and I will mute myself, but please chat in the chat box.
Hello, everybody, and thank you so much for joining us today. Let me go ahead and I'm going to share my screen. And so here we go, screen number 2. There we are, share. And so you should see a full view of the PowerPoint.
Yes. Yes.
All right, awesome. So before we get started, so first of all, happy 2024. Last time we spoke, it was 2023, which is so crazy to believe that we're already more than halfway through January. But last time when we spoke, we kind of laid a really nice foundation as it relates to organic acids and testing. And so I just wanted to kind of backpedal just a little bit and talk about what we discussed last time. So if you missed the presentation, you can catch up, or if you have 2023 brain fog, you can catch up as well, okay? So what we talked about was the who, what, when, and why of organic acids. So we focused on the who in terms of who can benefit. We talked about people who are, especially women, in transitional times of their lives in terms of their menstrual cycle, transitional times, and having babies. We talked about males, how they could benefit, people with chronic health conditions, pediatric patients, especially those with developmental concerns and nutritional deficiencies and behavioral and learning difficulties, as well as the aging population. We discussed athletes and those who are active and just as good preventative health. Those are individuals who can really benefit. The what of organic acids, that's when we really stepped into how do organic acids lead to recommendations for various nutrients. So we discussed how any given pathway has an enzyme that's required to convert one thing to the next. And that enzyme, most of them will require cofactors, which are vitamins and minerals, to help that pathway move forward. So in organic acid testing, we're looking at that pathway to see where are there hiccups or deficiencies or blockages in that pathway. And based on that information, we're able to figure out, well, how do we enhance the function of that enzyme? What nutrient is needed? That's how organic acids helps us to understand what cofactors, nutrients our patients might need. And so it's a little bit different than our traditional testing, because our traditional testing usually measures a nutrient to determine if you are deficient, if you have a risk for a disease of deficiency. Whereas with organic acid testing, we're looking at your biochemistry to see where are there insufficiencies, I guess we can say. We also went into the when to test. Now, when to test, I say, basically, if you eat food and you breathe air and you move, that's a great reason to consider testing. But for those individuals who especially have a new onset of fatigue or a fatigue that we just cannot figure out or explain, nutrition testing can be helpful. For those who are your optimizers, whether it's sports, fitness, or just moving into a new stage of life, this is another great test to consider. And then for those who have a new onset or mood disorders that we can't quite figure out the root, medications aren't working, doesn't seem to be a thyroid issue or anything else going on, those are the top 3 reasons why people order this test in terms of when to order the test. But digestive problems, hormonal issues, medications, how multiple medications can also deplete nutrients. So we want to know how that's impacting the person. People who have a poor diet, chronic stress, chronic inflammation, these are all cases of when we will consider testing. And then lastly, we finished up that first section with why choose the Organix profile. And so I kind of alluded earlier to conventional medical testing. Let's say, for example, if somebody is fatigued, we measure their iron to see if they are iron deficient, right? But when we look at organic acid testing, we're not looking to see deficiency in nutrient connected with the disease. We're looking to see more of that suboptimal deficiency states where you just don't quite have enough of that nutrient and you could be operating at a better level in terms of health. So the Organix profile has really actionable data in terms of if you see that this marker is low, then these are the things that we need to think about. It's clinically relevant because a lot of times when we look at the Organix profile, we can kind of understand what that patient has going on by just looking at the results, because there's typical patterns or certain markers that might indicate certain conditions. And then again, it's beyond our traditional functional testing. Now, where we kind of wrapped up last time we spoke was looking at 3 functional pillars. And the 3 functional pillars that we discussed were mitochondrial support, methylation imbalance, and toxic exposure. And so we are going to focus on those 3 pillars for today. I'm going to go through the individual organic acids, and we're going to talk about what pathways they're involved in and what to consider when things are high and or low. And then we're going to also discuss, as relates to organic acids, compounds of bacterial or yeast origin, and then we're going to explain the oxalate markers, which is one of the newer additions to the Organix profile. And so I really want to make sure we touch upon that because before we added it to the profile and when we were making the decision to add it or not to add it, There was a lot of historical context around oxalate markers. So I kind of want to bust those myths at first and then let you know what the current literature says. So that's kind of how we're going to go through the presentation for today. So you're going to see some slides that I pulled from the presentation last year onto this presentation because I really want to make sure, again, we have a baseline understanding as it relates to some of these topics. So for mitochondrial dysfunction, mitochondria is just an organelle within your cells, and its job is really to take your macronutrients, your fats, your carbs, your proteins, and to convert it into ATP. It's metabolization. That's what we call it, of your macronutrients, where we're generating energy. And so you're going to see in just a moment, and as I kind of alluded to earlier, there's a lot of different steps in the citric acid cycle. You might be familiar from, your schooling, your education, and each step, each enzyme can be impacted by not only not having enough nutrients or vitamins present, but you'll see quite a few of these enzymes can also be impacted by heavy metal exposures, and they can also be impacted by genetic polymorphisms. Although the Organix Profile doesn't focus on genetic polymorphisms, it is something to be aware of. Now, the nice thing is that if you have a genetic polymorphism, it usually does not shut down the enzyme. It just usually works either less or more efficiently. And so the same cofactors we're going to be talking about, that is still applicable even if there is a genetic polymorphism. And then also for the mitochondria, in terms of what diseases are associated with dysfunction, your neurocognitive, your diabetes, your cancer, your cardiac, your mood, your chronic fatigue syndromes, all of these are typically associated with the mitochondria when they are not operating at their best capacity. So these are the markers that we are going to focus on as it relates to mitochondrial dysfunction. So let's take each section at a time. So first, starting with fatty acid metabolism, we have adipate and suberate. So if you recall from biochemistry, for some of us, it was only 5 years ago, and for others of us, it was a long time ago. But here we're taking our fats, bringing it through the fatty acid carnitine shuttle into beta oxidation. The fatty acid carnitine shuttle requires not only carnitine, but also magnesium and B2 as cofactors. If we lack those cofactors, the body will redirect our fatty acids into what's called omega oxidation. That's a refined subearic acid and adipic acid. So again, if subearic acid or adipic acid are elevated, it's probably because we don't have enough either carnitine, which could be from vegan, vegetarian style diets or maldigestion, malabsorption, or we lack magnesium B2. The other thing to consider is that if there is an insulin glucose challenge, that will also alter how your body processes your fats. So if you see within the mitochondrial section that a lot of things are off, like how you process your fats and how you process your carbs, you might want to consider grabbing a fasting insulin as well as a glucose and an HbA1c for your patient, because that actually might be the root of why we're having trouble getting those macronutrients into the mitochondria. The next section is carbohydrate metabolism. For carbohydrate metabolism, you can see we're converting our carbs into pyruvic acid. Cofactor is magnesium. If pyruvate is low, it's because we're either eating a low carb diet, like a ketogenic diet or one of those style low carb diets, or we don't have enough magnesium to push the carbs forward into pyruvic acid. If pyruvic acid is elevated, it means we don't have the cofactors needed to move it forward into acetyl-CoA. So these are the cofactors listed here. It's not depicted, but I think it's still worthwhile mentioning heavy metals such as mercury, arsenic, and antimony can also impact how we move pyruvic acid into acetyl-CoA. This particular enzyme is a dehydrogenase enzyme, and it's very susceptible to those specific heavy metals. So again, if pyruvic acid is elevated, it could be that we don't have enough B1, 2, 3, 5, and or alpha lipoic acid, or the presence of a heavy metal. And as I mentioned earlier, it could also be an insulin glucose issue. Lactic acid, most of us are familiar with lactic acid as it relates to when you go to the gym, you work out, and a few days later you feel sore. That lactic acid buildup in the muscle tissues due to oxygen deficiency and working out. Same thing here. It can be elevated from a new exercise regimen, but any form of oxygen deficiency can elevate lactic acid, including sleep apnea, asthma, COPD, and even being anemic. Now, zinc and oxygen are required to help lactic acid move back into pyruvic acid, but I like to think of lactic acid as like your anaerobic way to process your carbs and pyruvic acid as your aerobic way to process your carbs. Beta hydroxybutyrate, number 5, that deals more with ketogenesis. And so as you can imagine, if you're making ketones, maybe it's because of a ketogenic diet, intermittent fasting, a low carb diet, and that's normal. But you can also make ketones with anorexia, starvation, especially insulin glucose issues. So again, if we have high amounts of ketones, we want to try to understand, is it intentional or is it not intentional? If it's not intentional, then we will probably have to run some blood work to evaluate insulin glucose. And then I've ran across profiles where the clinician wasn't quite sure if the patient had an anorexic eating restrictive disorder problem. And so I suggested that we just run amylase lipase, which if you guys don't know, that's a really quick way to see if your patient has anorexia or like some kind of an eating restrictive disorder, because it basically throws off the pancreas and it can lead to abnormal levels. So just FYI, a little side note there. But again, with beta hydroxybutyric acid elevation, we want to try to figure out, why are you making more ketones? Now, I have some clients who've asked me, could it be due to the fasting that was done to prepare for your sample collection? And the answer is no, because the reference range for number 5 was built off of fasting individuals. So if something happened where the patient ended up having to fast for an extended period beyond the recommendations on the collection instructions, absolutely, that can cause ketones to elevate. But for the person who just took their first morning void, like recommended in the collection instructions, who did the fast starting, the few hours prior, then we should be okay. So this next section is energy production, whether you want to call it the citric acid cycle or the TCA cycle. So here you can see, starting off with, it's coming from acetyl-CoA, but here you see citric acid. Now, the reason I left the amino acid sign here, and we didn't talk about it earlier, is because amino acids are a little bit different with their citric acid cycle. They actually can filter in at several steps of the cycle. So if you have somebody who is deficient in amino acids, it's not uncommon to hear, I'm tired. Well, that could be that your citric acid cycle is not running efficiently, producing that ATP that's needed. So another small trick is, if you see a lot of the citric acid cycle intermediates trend low, check their amino acids, check their protein consumption, see if they're athletic and running through the amino acids super quickly, see if there's digestive issues, or check out their diet style. So when we look at the actual cycle, another pattern I look at before I go to the individual markers is, do we see a high trend? Because if we see a trend where the majority of these intermediates are on the higher side, that either indicates B vitamin deficiency, CoQ10 deficiency, or some kind of a mixture with both of them. So when we look at them individually, you'll see the citric acid requires Fe, which is iron, and GSH stands for glutathione. It's not that glutathione is a cofactor. It's that oxidative stress slows this particular step down. So antioxidants will help move that pathway forward. So citric acid and cis-aconitic acid, you'll see, have similar cofactors because they use a similar enzyme called aconitase. So if these two are elevated, or one of them is elevated, and your patient is presenting with fatigue, then we definitely want to check what is your fasting, not fasting, but what are your iron levels to see if that might be a potential issue. And then for these red bubbles here, they're just representing heavy metals. So if you're exposed to fluoride, mercury, arsenic, antimony, that's another reason that citrate or cis-aconitate can be elevated. So it's either elevated because we don't have enough iron. It could be elevated because we have too much oxidative stress and we need more antioxidants, or the presence of fluoride, mercury, arsenic, antimony. The next one is isocitric acid. So for isocitric acid number 8, if it is low, you have to look backwards to see why is it, what's not converting into. So that could be cis-aconitic acid not converting into isocitric acid if it's low, and then you would look at these particular cofactors and heavy metals. But if isocitric acid is high, then you have to figure out why is it not moving forward into alpha-ketoglutarate acid. And here are the cofactors: B3, magnesium, manganese, as well as aluminum can slow it down. Number 9, alpha-ketoglutarate. To move it forward, we require magnesium, B1, B2, and B3. Not listed here, but still worthwhile mentioning, is mercury, arsenic, and antimony can also cause the alpha-ketoglutarate acid to kind of accumulate and not convert forward into succinic acid. For succinic acid, we see the cofactors when elevated are iron and B2. So again, if this is elevated, we do want to check iron levels. Now, again, what's not represented here, this is a very simplistic diagram of the citric acid cycle, but what's not represented here is how methylation actually feeds into number 10, succinate. So if there's issues with B9, which is folate, or B12, or methylation, the succinic acid or succinate can be low. So keep that in mind. And then fumaric acid's not measured on the profile at this particular step. This is where we join water into the cycle. And then malic acid or malate. So if that's elevated, we look at not having enough B3. Please understand that malate is used in many beverages, and it's used even in supplements. It has a tart taste to it, so it's used as a flavor enhancers, especially for like your sodas and unhealthy beverages and candies as well. Malate is also found naturally in apples. So if you have a patient who loves apples, well, that could be a source of malate. But it can also indicate B3 deficiencies. Now, there was an observation study that was done, and it was super fascinating in my opinion because it was done on animals. And I never talk about animal studies because we all know there's a difference between how animals operate and how humans operate. But in this particular study, they noticed that through observations that malate was high in those animals that had an induced hypothyroid and an induced insulin glucose dysregulation. And so the reason I get excited and I think it's super interesting is because, excuse me, I actually see this happening in humans too. So whenever I see malic acid high, I question, do you have constipation or cold intolerance? Are you gaining weight unexpectedly? Could it be a thyroid issue? Or do you have polyuria, like you're urinating very often and you have unquenchable thirst and you might have some blurry vision or dizzy? That could be insulin glucose issues. So definitely when malic acid is elevated, I ask the specific target questions about thyroid and insulin glucose to see how are we doing? Do I need to follow up with standard testing? And the very last one here is hydroxymethylglutarate. So this is also called HMG. So you guys are pretty familiar probably with the drug statin and how statins lower cholesterol through HMG CoA reductase. That's the enzyme it works through. Well, this is HMG, H for hydroxy, M for methyl, G for glutarate. And so if this is elevated, it indicates that we have a need for CoQ10. Whether it's because we're on a statin, a beta blocker, or diabetes medication, or it could be that we have fat maldigestion, malabsorption, right? Because CoQ10 is fat soluble. But when this is elevated, we do need to think about CoQ10 need. So let's transition into methylation imbalance. So as it relates to methylation, it's very fascinating, in my opinion, because it's this carbon attached to 3 hydrogen molecules. And whenever it moves from one place to the next, it impacts a lot. It impacts hormones, it impacts cardiac, it impacts DNA, it impacts detoxification, your liver. So this really small molecule, when it's moving around billions of times per second throughout every single cell in the body, it has a huge impact. And so as you look at this profile right here that you're seeing, this diagram is from the methylation panel. So it's not on the Organix profile, but I want to show you every time you see a blue square, that's another enzyme. So these enzymes each have cofactor needs. So you can see here, if we don't have the right nutrients or vitamins, then it's going to mess up methylation. But also we know about genetic polymorphisms. A lot of us are familiar with MTHFR, which is the enzyme right here. I know it's a little bit small, but it's right here, the MTHFR enzyme. So if there's a genetic polymorphism, the enzyme works slower, which could lead to an accumulation of homocysteine because we're not able to move that folate cycle fast enough. So genetic polymorphisms also impacts this. I want to show you something. Just like every other enzyme, there's cofactors. So even if MTHFR has a SNP and it's not working efficiently, the cofactors are still B2 and B3. So you still need B2 and B3 for the MTHFR enzyme to work. So I always find that very fascinating that in the medical community, we've really said MTHFR SNP, B9. We don't really stop and consider B2 and B3, which is a shame because obviously it's very important here. Methylation imbalances, you can see the diseases associated with, very similar to mitochondrial dysfunction diseases. We have some cardiac things, some diabetes, neurodegenerative, mood disorders, liver disease, inflammatory things, obesity. So very similar to what we saw for when we looked at the mitochondria and its dysfunction in terms of things that can be associated with when methylation does not go right. So on this next section, nutrient markers, we're still going to talk a little bit about mitochondrial dysfunction, how some markers might influence it, but we're also going to transition into methylation imbalance as well. So for these first 3 markers, these are your B complex vitamin markers. They come from your branch chain amino acids, isoleucine, leucine, and valine. Now, these amino acids are a little bit different because they're first processed through skeletal muscles, unlike any other amino acid. So these deal with gluconeogenesis. And so I say that because I also want you to think when these 3 are elevated, these 3 alpha keto acids are elevated, also think about insulin and glucose. See if they're regulated well. But look at the enzyme is right here, and look at the cofactors, B1, 2, 3, 5, and alpha lipoic acid. If you lack the cofactors, these markers can also accumulate. This next section, we have 16 through 20, alpha keto adipate. So this one, when elevated, indicates the need for B1, number 16. Now, where did we see B1 in the mitochondria? We saw it with the enzymes, particularly called dehydrogenase. They required B1, 2, 3, and 5 in alpha lipoic acid. So if you recall pyruvate and alpha ketoglutarate, those are dehydrogenase enzymes that requires B1. So if we don't have enough B1, this could drive high. Number 17 and 18 are both biotin markers, B7. So although not represented on the citric acid cycle or the TCA cycle, there's a process in the mitochondria that occurs called carboxylase. And so it's basically, carboxylase is a biotin-dependent enzyme, basically. So if you don't have enough biotin B7, it can interfere with the carboxylase enzyme, which interferes with your mitochondria. Okay, there's actually some really interesting information that's starting to kind of surface as it relates to B7. When it's deficient, we think about mitochondrial issues, but we also think about neurodegenerative disorders. And the information that's starting to surface is more animal based, but it's interesting because it talks about this deficiency of the carboxylase and the biotin kind of complex in those animals that has an issue as it relates to B7. So again, just showing you that link between neurodegenerative disorders, mitochondria, and how B7 playing a role with the carboxylase might fall in there. The last two, 19 and 20, are both B2 indicators. So when it comes to vitamin B2, remember again for the dehydrogenase enzymes, we talked about that, but I also just showed you how B2 is important for your MTHFR enzyme. But B2 is also important for helping us to convert B12 from the oxidized state, in which we cannot use, back into the reduced state so we can use it again. That's B12. So B2 is needed for B12 as well. Okay, so you can kind of see how, as it relates to mitochondria, but also methylation, vitamin B2 is essential. Now, the methylation cofactor markers, that's what we're more familiar with as it relates to methylation. So if you take a peek here, you'll see methylmalonic acid or methylmalonate. When it's elevated, it's because methylmalonyl-CoA doesn't have enough B12 to go into succinic acid. This is like a fork in the road. You either have B12 or you do not have enough. So that's why when methylmalonic acid is elevated, we consider B12. Glutamate or glutamic acid, when that one is elevated, it usually indicates that we don't have enough THF, tetrahydrofolate, or B9 to move it into glutamic acid. Now, the caution that I always like to tell people, actually just had a conversation with a clinician earlier today, is there's this idea of overmethylation. We might not be familiar with that term, but if you've ever given a patient B vitamins and they reacted poorly in terms of, I had increased anxiety, I was more paranoid, I socially isolated myself, I was high energy. If you've ever seen any of those symptoms from a patient that you gave methylated B vitamins to, that actually might be caused by overmethylation. Unfortunately, there is no way to define overmethylation. In terms of like specific biomarkers, there's just this phenomenon that occurs. And so my caution is, when giving patients methylated B vitamins, especially higher doses, you want to make sure that they're not in a position to overmethylate. Well, how do we do that if there's no way to define it? Well, I like to look at their homocysteine. Ideal homocysteine is about 6 to 8. If their homocysteine is a 6 or lower, you're really risking overmethylation. And so for homocysteine levels at 6 or lower, I try not to give additional methylated nutrients. And if it's really low, like 4 or something, or 5, and they have these symptoms, then I reduce the amount of methylated vitamins that they're taking, and I switch it with unmethylated nutrients. Easier said than done, right? Because most of your supplements nowadays, I know we access from the US, a lot of them already have methylated nutrients in them. But there are some companies that do offer non-methylated B vitamin support and multivitamins as well. So more specific to methylation imbalance, we have these cell regulation markers from neurotransmitter metabolism. So let's focus on the first 4 here. So whenever they trend low, your neurotransmitters, you have to look back at what the precursor is, which is going to be an amino acid. So the precursor to venomedyllate, which is the metabolite of norepinephrine, epinephrine, the precursor to homovanillate, which is the metabolite of dopamine, is going to be phenylalanine that converts to tyrosine. So if we don't have adequate amino acids or the ability to convert phenylalanine into tyrosine, that's why homovinylate and or vanomedelate can be low. Now, some of you all might not be familiar with this tetrahydrobiopterin, also called BH4 pathway. Basically, this is a pathway that converts arginine into nitric oxide. It converts phenylalanine tyrosine into norepi-epi and dopamine, but it also converts serotonin, or it converts, tryptophan into serotonin. So that tetrahydrobiopterin pathway requires iron, vitamin C. Those are kind of like the big ones, as well as B9. Okay, so that's what that means. So if you have somebody who has adequate tyrosine levels, good amino acids, but yet their homovinylate vanomedelate is on the low side, it could be that biopterin pathway, the BH4 pathway. Again, vitamin C, iron, as well as B9 or folate. But generally, we tend to see vanomedelate and homovinylate high. Well, we first want to look at their medications and supplements. If somebody is on an SNRI, because it not only reuptakes the serotonin, it also reuptakes the norepinephrine, then vanomedelate can be high. If somebody's on a DOPA medication like Parkinsonians or something, then that could lead to a higher homovinylate. But I want you to look, how do we convert dopamine into norepinephrine and epinephrine? If you see here, it says ascorbate, which is vitamin C, and copper. So if ever you see high homovinylate and low norepi-epi, that could be insufficient vitamin C and or copper. And why would you have insufficient copper? Well, we're kind of, around this pandemic time, we've seen a lot of copper deficiencies. Why? Because people are taking high doses of zinc. What does zinc do to copper? Competition. So whenever you see this issue with the conversion, you want to ask, are you taking zinc? How much? And look at their diet to see if it's balanced out with copper. I don't give copper. Usually copper is very easy to get through your diet. Shiitake mushrooms, I prefer the chocolate route of copper, but that's just me personally. So then we have this last one, which is 5-hydroxyendylacetate. Oh, I'm sorry. Let's go back. Number 25. I apologize. So number 25, 3-methyl-4-hydroxyphenylglycol. Where this comes into play is this marker 25 converts into vanomedelate. So it's also a metabolite of norepinephrine, epinephrine. The enzyme that converts number 25, 3-methyl-4-hydroxyphenylglycol, into number 23 is ADH, aldehyde dehydrogenase. So alcohol impacts that, liver health impacts that. But listen to the word. I said it's a dehydrogenase enzyme. And what did we already see with dehydrogenase enzymes? They have similar cofactors, right? So B1 and 2 and 3, but also alpha-lipoic acid. Number 26, 5-hydroxyendylacetate, or 5-HIAA, is the metabolite of serotonin. And so as it relates to serotonin, the reason I put it under methylation imbalance is because you guys might be familiar with the SERT transport protein for serotonin. Well, basically, it deals with gene expression of serotonin. And so if you don't have adequate methylation, then transport protein does not work effectively. Again, it's the SERT. So that's why I put it under this methylation section here. So with this one, number 26, it's again from tryptophan converting into 5-HTP, converting into serotonin. So if it's low, we might not have enough tryptophan. But if it's high, it could be, first of all, medications, right? Think about 5-HTP or tryptophan or melatonin or even an SSRI, ADHD medications, SNRIs, acetaminophen, guanfacine, expectorant. There's so many medications and supplements that actually impact serotonin. And so if we are on those medications, it's normal for the serotonin metabolite to be elevated. Serotonin metabolite can also be elevated if there's GI dysbiosis, right? I think it's 70 to 75% of your neurotransmitters It's impacted by your gut, whether it's produced there or cleared there. So it could be gut dysbiosis leading to problems with serotonin when this is elevated as well. The other thing we think about is maybe you're just not clearing it properly. So B vitamins, magnesium, and manganese can be very helpful as cofactors to help clear out that serotonin metabolite as well. Now, personally, I also like to consider when our neurotransmitter metabolite markers are a little bit off. I like to consider looking at adrenal health. What is their diurnal patterns of cortisol production, especially with this norepinephrine marker, Vanna Mandela, if that's elevated. Sometimes it can be elevated just because of, B vitamin issues. But sometimes we need to go back and look at what are the adrenals doing. Now we're going to transition into toxic exposure, and then we're going to step back and cover the latter part of that neurotransmitter section. So as it relates to toxic exposure, again, this is a slide that we got from the previous presentation. So these urinary markers can reflect exposure to environmental toxins. It can reflect some kind of a change in our detoxification pathways in response to exposures. So always the recommendation is to figure out where is it coming from, and then you want to minimize your exposures and then make sure you can remove them. Make sure your detox pathways are opened. We call them your emunctories here. So make sure you're urinating well, you're hydrating well, you're sweating well, and you have regular bowel movements. But also we can use nutrients like your B vitamins and your antioxidants to support detoxification as well. I'm going to throw in this word oxidative stress here, but what oxidative stress really is it's just basically you have more free radical production versus the amount of antioxidants that you have available in your body. That's basically what oxidative stress is. It's an imbalance. And so when we look at 27 through 30, we're seeing it's the tryptophan, now not the tryptophan serotonin pathway. This is different. This pathway's goal is to make NAD, which is the active form of niacin, which is B3. Now, what's interesting is, I oftentimes ask myself this question: why would the body choose the NAD pathway versus serotonin pathway with tryptophan? The answer is a lot of the articles point to oxidative stress. Now, oxidative stress can come from a toxic exposure, but oxidative stress can come from literally anything, right? So whenever I see that this 27 through 30, things are looking a little bit on the high side, I ask that question. Oxidative stress? Why? Where? Especially when it's elevated alongside the 8-hydroxy-2-deoxyguanosine, which is a marker of oxidative damage already done to DNA, hence guanosine, one of your DNA building blocks. I ask the why, the where, the how kind of questions. Personally, I like to start with just basic blood work, right? CBC, CMP, thyroid, ANA, and insulin, just to see if something pops up. Look at the family history to see if I have to investigate something. It could be environmental. It could be a chronic infection or acute infection. It could be training for a marathon, right? That can lead to oxidative stress as well. So really trying to figure out the root of oxidative stress, because anybody can take antioxidants. Any clinician can give antioxidants, but it's the skilled clinician that figures out why do we have oxidative stress in the first place. So hyaluronic acid, you'll see B6 sprinkled throughout here because B6 is very important for this B3 pathway. I know, whatever. It's kind of awkward, but trust me, it is very important. So when hyaluronic acid is elevated, we think about not only B6, but also B2 and B3. The quinolate, when that is elevated, a lot of us start to think about not only oxidative stress, but inflammation in particular. When you look in literature about quinolic acid or quinolate, it talks about neurological inflammation. In fact, the highest levels of quinolate that I've ever seen were in people that had seizure disorders and tic disorders. Neurological inflammation, right? Now, just because this is elevated does not mean you need to go run to a neurologist, right? This can also be elevated because of arthritis, inflammatory bowel disease, So any inflammation can cause the quinolinic acid to elevate. Another thing we have to consider, hormones. So if you have a patient who's on bioidentical hormones or synthetic hormones or ART, which is like assisted reproductive therapies for fertility, that can drive the quinolinic acid up as well. Now, what that causes is the ratio to go down. So it's not just about high quinolinic, it's also about the ratio. If the ratio is low, we also concern ourselves with, are you on some kind of a bioidentical hormone or any hormone at all, and or what's going on with inflammation? Usually with a low ratio, I'll see an HSCRP, a CRP, a ESR, or some kind of standard inflammatory marker also showing that we do have inflammation. Xanthronate is very specific to needing vitamin B6 in this pathway. We already touched upon the oxidative damage antioxidant marker. A lot of people get scared. They're like, damage to my DNA. Oh no. Well, rightfully so, right? However, it is reversible. I always like to tell people it is reversible, okay? And so, again, whenever there's oxidative damage that we see here to this DNA, standard blood work, try to figure out where it's coming from, make sure we have good antioxidants. So still along this toxic exposure oxidative stress, we have a few more additional markers. So orotate, number 32. Think about your urea cycle. In the urea cycle, the goal is to basically clear or detoxify ammonia. That's not only produced from your body, but we also get it from eating animal meat products. So if the orotate is low, it could be that you're more vegan vegetarian in diet styles. But if the orotate is high, it could be that we don't have enough arginine, which is a very important amino acid to help that urea cycle to operate well. It could also be high due to liver detox issues, because when you think about it, your urea cycle happens in the liver. So if the liver is not operating optimally, then it could definitely also cause the orotate to elevate. Now, there are a few medications like gout medication, barbiturates, and alcohol that can also drive this up. For the other marker, alpha hydroxybutyrate, this one is another oxidative stress indicator. We do typically think about needing glutathione antioxidants when it's elevated, but this is another indicator that we see high with metabolic syndrome again. So insulin glucose issues. So when that's elevated, we do want to think about looking at standard blood work. Pyroglutamate is involved in the glutathione cycle. So if it's low, we might not have the right cofactors to build glutathione. So that would be glutamine, glycine, cysteine. But when it's high, it could indicate that the glutathione cycle is working too fast, and we want to figure out where's the oxidative stress. Now, please remember, glutathione exists in two states, oxidized and reduced. We don't use oxidized, we use reduced. So you have to convert oxidized back into reduced. That could be another reason that that cycle is working really fast. Now, how do we do that? You have vitamin C, alpha-lipoic acid, selenium, and milk thistle. These are ways that we can help move it back into that reduced state. Alpha hydroisobutyrate is a metabolite of a gasoline additive called MTBE. And so this gasoline additive, it's been banned in the US, but I know it's used in other countries still as a gasoline additive. In other industries, it's still used. But this one is usually from either the gas pump, breathing it in, or it's really water salt. It's like it hangs out in water. So oftentimes I'll tell people, check out your water filtration, be careful in public. Usually the water filtration system that's certified to clear this is Carbon Technology. The alpha ketophenylacetic acids from styrene, think about styrofoam, plastic containers, Tupperware, but those things can be avoided, right? But even if you have, let's say, new flooring, new carpet, new insulation, anything remodeled can also provide sources of styrene, and so you'll have to air it out and then support detox. So for the compounds of bacterial or yeast origin, and these latter two sections are pretty short, so we'll still have some time for Q&A. But for the compounds of bacterial yeast origin, whenever these are byproducts, okay, from bacteria and fungal activity in the GI tract. but many of these can be a result of fermentation of dietary phenols and flavonoids. So when these compounds of bacteria, yeast, fungal origin are elevated, what's the patient's diet? Because if they're doing berry smoothies every day, well, that could elevate it. If they're doing elderberry syrup or some kind of a phenolic or flavonoid concentrated product, like EGCG, which is the extract of green tea, that could cause it to elevate as well. But basically, whenever you look at the overall trends, if you see a trend where most of them are elevated, we want to think about dysbiosis or some other type of GI dysfunction. So benzoate, hippurate, and again, all these can be influenced by those phenolic polyphenol compounds, okay? But for benzoate, hippurate, when elevated, I definitely do think about, well, do we have a bad bug present in the GI tract? Do you have gas? Do you have bloating? Do you have changes in your stool habits? Phenylacetate, endocetic acid, these next four, again, thinking about those same things, but also sometimes, number 39 especially, I think about this, it could be a digestive issue. So I do ask about also upper GI symptoms as well to see if it's more digestion, or could it be more bad bugs, or is it just coming from your diet? This freaks people out a little bit when they say Clostridial species because they think automatically C. diff, which I get it, but there's many Clostridial species that are commensal to your gut. It's just the C. diff that's a problem. That's the toxic toxin problem one. So if this is elevated, again, we want to ask about those typical GI symptoms. Do you have anything that changed? And then following up with appropriate testing would make sense. Obviously, if they have bloody stools, urgent stools, then, we want to do a C. diff test, okay? And then for the yeast fungal, diarabinitol is a little bit different. This is specific to Candida. So when this is elevated, I like to reduce sugar, yeast, and molded foods and beverages, ask about symptoms of yeast overgrowth, like skin, itchy, bumpy rashes, or carbohydrate cravings, or mood changes, things like that. And then treat if they are symptomatic, obviously. And then 45, 46, although yeast fungal markers, they can also be influenced by the phenolic compounds in the diet from like berries. So also keep that in mind. If they're elevated, learn the patient's diet. For the oxalate markers, one of the newer additions to our nutrition testing, historically, when we thought about oxalate markers, we linked it to yeast. Now, our forefathers, I'm not disrespecting them, I promise. That might have been a pattern that they saw, but the current literature does not say anything about oxalate markers and yeast. The current literature talks more about oxidative damage, metabolic dysfunction, catabolic physiology. So the glycerate, which is this first one here, glyceric acid, you can see that if it is low, it could be that we don't have enough kind of cofactors to drive it into glyceric acid. So that includes things like fructose, and amino acids. So those can cause the glyceric acid to be on the lower side if we're not eating enough fruits and vegetables, or we have low amino acids. But if it's high, it could be a need for B3 magnesium, which are the two pathways needed to clear it out. And these are conditions we do see it high in, although not diagnostic. Oxalic acid and glycolic acid, so you can see it comes from collagen. So if you have bone breakdown like osteoporosis, osteopenia, or if you're taking collagen, guess what? These two can be high. But they can also be high if you don't have enough B6, because B6 drives the pathway up. So if you don't have enough B6, it'll drive the pathway this way. And then you can see here, oxalic acid, we think about, do you have kidney stone risk? If you do, let's minimize oxalates in the diet. And glycolate, if that's high, it comes from where? Oxidative damage. There again is that glutathione, but we also see it high with metabolic syndrome kind of issues. So insulin, glucose again. So as before, this is the end of our conversation. You can see that we are the end of me talking. I'll let y'all ask some questions, but you can see here we have some educational resources, and I will go ahead and, oh, that's my face. Hi. I'll go ahead and I'll turn over everything to our wonderful co-founder here.
Thank you for that presentation. And yeah, time flew very, very quickly. So I just love organics tests and all the markers and the biochemistry around it. So I'm having fun.
Okay.
So, and lots of questions did come up. So it's a complicated test and it gives a lot of indicators. Before we just go into some of the questions, I just want to, because you said something about genetics and organics, and actually what I really much like doing is pair DNA health from DNA Life with the organic acid testing, because there's a lot of like overlaps. Then you get the genes on the foundation, and then you have the actual levels. You have the genetic information about methylation, and then you have what goes on through the organic acid. So it's very nice to have details like that if possible, and to get get the patients so convinced that they could do a test pair like that. So then there was a question about because you mentioned dehydrogenase enzymes several times, and is it all dehydrogenase enzymes that are impacted with heavy metals, so their activity gets destroyed with heavy metals?
Yeah, so dehydrogenase is actually a few times within the citric acid cycle. So you have pyruvate, you have alpha ketoglutarate, and then isocitrate has a dehydrogenase enzyme as well. And so, yeah, heavy metals can impact them. Depending on which dehydrogenase enzyme it is, a different heavy metal might impact them. But yeah, it's something that we have to be mindful of, and it's not always the root, but let's ask the patients those questions. For aluminum, are you exposed to cooking utensils, antacids, deodorant, beauty products, right? For mercury, shellfish, seafood, dental amalgams. For arsenic, shellfish, seafood, but also wood, like something rebuilt in their house, because we use arsenic to kind of preserve wood to make it not rot, right? So that's another thing, like when people get new hardwood floors in their house or a new deck or something like that. Antimony, a lot of flame retard textiles. So unfortunately, it's gonna sound bad, but all those clothing that we put on kids that say they do not burn, well, a lot of that is actually chemically treated, sometimes even with antimony. And then fluoride drinking water.
And then a very serious question came, is there like a pill so we can download all your information into our brains? I thought that was quite cute.
So that is a very, that is a very scary pill that I would not take.
Yeah, you don't know what comes with.
I know, yeah, what comes with it is kind of scary. Oh, but that's a very high compliment, and I thank you. I thank you.
So then, there was a question in the beginning as well about amino acids being high. So I guess a person having enough protein and digesting and absorbing protein enough, but having low citric cycle markers.
Yeah.
Comment on that, please? Because I know there is a pattern recognition where when you have low markers, or actually marker 1 to 19, I think it is, if they're on the low side, there's a pattern that it could be like an amino acid deficiency. I remember Richard Ford at least was talking about that. So
Yeah.
maybe give us some clues on some pattern recognition there.
Yeah, absolutely. So if the citric acid cycle intermediates are low, you do want to look at amino acid intake or protein intake. Are they athletic? Are they pregnant or breastfeeding? Running through those amino acids really quickly. What's their diet? See if there's some kind of a deficiency in those amino acids, right? But for individuals who have low trends in the citric acid cycle, but their amino acid looks good, then we're just going to go back to these cofactors here. Does that make sense? So let's say, again, if alpha ketoglutarate acid is low, then we have to figure out why is it not converting from isocitric acid, and these are your cofactors.
Super.
That's a really good question. Yeah.
And then when you went through the dysbiosis part, you did not, and maybe that's a new thing, but you did not comment on the benzoate hyporate ratio.
Oh, yes, yes. So the benzoic hippurate ratio, absolutely. I think that's important to be mindful of as well. I didn't comment on it. You're actually correct. Sorry about that. But with that one, oftentimes, if the ratio of them are a little bit skewed, I do question environmental exposures, which is why sometimes you'll see with benzoate and hippurate, some clinicians will speak to the use of glycine, which basically will help to feed into making glutathione for detoxification. One of the things I think about is actually called not styrene, it's xylene. That's what it is, xylene. And so xylene, think about paint, varnishes, decorating material finishes. They oftentimes will use that chemical. And so I do oftentimes see it high in people who moved into a new house or they got something remodeled or something like that.
Super. Thank you. And then I have a question, and that's because and it's just more if you know the mechanism of action, because you said gut dysbiosis and high 5 HIA. And I was just thinking more like, is that the dysbiosis making the gut create even more serotonin, or is it not being metabolized? And then do you have can you explain the mechanism of action?
So
Or
okay, so as we're all aware, the microbiome is still the up and coming, developing kind of science. Okay. So from my understanding, and literally I might listen to this recording in like 3 years and totally laugh at myself and be like, oh, you're so silly. Right. But from my understanding, it's the metabolization of it. So how the gut metabolizes that serotonin, it's not as efficient as if you had good gut microbiome balance. So think about your gut bugs. They have the ability to also make metabolites as well. So this is where I think about it more for metabolization, but they also have the ability to produce things. So it could also be that you have an imbalance in the gut bugs that are able to metabolize the foods, not metabolize, but I guess I should say ferment the roughage and different things that come down from your digestive tract to make those metabolites. So that could also be a part of it as well, because we know that the gut microbes can help with GABA, not only the production of GABA, but breaking it down. And although I'm not aware of specific bugs that can do the same with serotonin, I would not be surprised if there was. So I think it's, in my mind, it's more metabolization of it, but I wouldn't be surprised if there's like a group of gut bugs that also can make serotonin.
There's something there. There's a pattern there that I've seen very often when there's gut issues, and then that is high, and they're not on antidepressants, and so I have like, but it's a big question mark to me. So it's good to hear that.
It's a question mark for everybody. Yeah. But what I think is very interesting, honestly, is that in your world of mental, emotional, mood, psychiatric medicine, you're now seeing them give out as first line of defense high dose probiotics. We're seeing it here in the US. And it is just so refreshing because that gut brain connection, it's starting to become more popular, mainstream, and it's starting to be accepted by multiple clinician types. And I think that's super exciting. And again, we're still really new in the microbiome in terms of the science. It's not that long ago that we were, as clinicians, tasting our patients' urine to see if they had diabetes. I mean, think about it. It's not that long ago, right? So the science is going to continue to progress. But yeah.
Then a question came up because we do have several organic acid tests, and then the main difference between the organics and the metabolomics. And I would say, I'm just going to do it the way I do it, because we also have the oat tests through Mosaic. And so I'm just going to quickly go through all of them. So the organic acid that we've been doing today, Organix, that's, if you just want to do that test, you get all this information. This is the only test you want to do. If you want to do metabolomics, and you're allowed to comment as well afterwards, but if you do metabolomics, you're getting all what you're getting in the organics, but you have the option of adding on other markers. So you can add on vitamin D, you can add on fatty acids. You're also getting more information about amino acids, and you can also get information about minerals and toxic elements. So that's if you want to, so I would do that if I want to add on all the other things, or if I want to know more about amino acid testing. And then we have the oat test from Mosaic, and I would choose that if I wanted to combine the testing with understanding something about mold. So you kind of have to choose your test as what type of patient is it that you have, what's the finances for, what else do you want to need, and what want to know about this patient. Is that how you do things?
Yeah, just one thing, the metabolomics test does not have vitamin D. Okay. So everything else you said is absolutely correct. So it has the organic acids, and you have the option to add on a blood spot fatty acid, and it does come with the amino acids. And you have the option to add on a urine heavy metal profile. Just understand urine heavy metal profile is just the past 24, 48 hours of exposure. So, definitely keep that in mind when you're trying to figure out where things are coming from.
Because at Nordic, we have an add-on vitamin D.
Oh,
Yeah.
you guys are fancy.
It's just
Jealous?
you guys.
Don't tell people in the States that. They'll be jealous.
So you can, so through Nordic and DNA Life, you can add on the vitamin D, but
Nice.
yeah.
Ooh.
So then one asked, and now time is, but it's so exciting. So if you have another 3 minutes.
Oh, no. You guys are fine. Go for it. No, I'm here. You're okay. Everybody else can wait. I like y'all. Y'all are fun.
Clostridia is the one that we are moving a little into.
Mhm.
Just because very often when we have a patient who has a high Clostridium marker, we don't necessarily have a really poor patient with like violent diarrhea, or we might have a semi-functioning person, or a behavioral child, or some who's on the spectrum of autism, etc. So and then from my understanding, it doesn't necessarily have to be like a pathogenic Clostridia, but it's still a dysbiotic Clostridia, and it shouldn't be there. But yeah.
Yeah, that's a really hard conversation, honestly, because there are some articles that are linking autism and behavioral disorders with this particular clostridial species. And as you mentioned, not all clostridial species are going to lead to that violent diarrhea, that potential, abdominal cramping, that's like, bend over kind of pain. And so what do we do in these cases? Do we still treat? And I usually leave that up to the discretion of the provider. And I usually say this should be an individual case decision, right? So the good news is that as it relates to treatment, we know that Clostridia is gram negative, right? So a lot of your common herbs that you are familiar with, like garlic and berberine, they can take care of it. And your common prescriptive agents like Bactrim or trimethoprim sulfa or tetracycline or Cipro, which I don't really like, but it can, take care of gram negative as well. I do have clinicians that work heavily with the autism behavioral disorder spectrum, and it's not uncommon for there to be a global dysbiosis in a whole bunch of stuff. And when you treat these kids, there are some improvements and even some progressions in areas that they were stagnant or declining in terms of behavioral and learning and cognition. So I don't know if it's a very clear, definitive high number 43, we need to kill it. I don't think that's how it really is. Again, I just take things on a case by case basis. The information is just a little bit still mixed. It's not very clear, but I do have clinicians that do use it as an indicator, especially if that patient has GI symptoms, and they will go ahead and treat. And what's nice is that, again, a lot of our common treatments we use for botanicals do cover gram negative bacteria.
Absolutely. I think that's it for now. You've done a sterling job. Thank you for an excellent presentation, and everyone, like, you're a gem, and yeah, you should go through the little comments down there. So thank you very much for sharing your knowledge, and I hope that at some stage we would be able to invite you again for a follow-up to this or something else. We'll see. And of course, we will share the recording and your slides with everybody who attended today. We were 115 people live, so well done everybody for having fun with us. And please reach out to us if you have any questions. And again, thank you very much for your time, Dr. Powell. It was
thank you. Thank you. Well, bye, everybody. Happy 2024.
Likewise, and see you soon, hopefully. Bye.
If you do not already have an account with us, please contact our team and we will assist you. If you found this webinar helpful, please like and subscribe to our channel.